quick video of my little emergency power station here, and camping power station, whatever you want to call it. Started with a 200 amp hour lithium iron phosphate battery, and just kind of started building on that. I've made this mount that encloses the whole battery. So those are the feet. Come up here with a piece of plywood to hold all the components. Main switch, 150 amp fuse, and then here's the smaller fuses where you have outputs for USB, and then the traditional cigarette lighter. And then here we got the Anderson power pole connectors, which is what I use on all my 12-volt stuff. And this is not finished. Got a few more things I've got to add here, but it is operational right now. One thing that I just temporarily attached in place is a soft turn on for the inverter. This is an inverter I've already had that I bought about 15 years ago. It's a what is that, Xantrax? It is a modified sine wave 1750 watt inverter. So I've got him mounted here on the side with plenty of airspace in between the inverter and the battery. That was kind of my design goal with this, is to have good airflow around everything. And so I added this soft turn on here. And yes, this will become permanent. What this does, I'm running through a 10 ohm resistor to slowly charge up the capacitors on the inverter to avoid a big current surge when you initially turn it on. So now we've got 13.2 volts. Now I can switch on the main switch. 13.3. And this is a backlit display. And then I've added these toggle switches for, there's the USB outlet, cigarette lighter, and then I call it PD8, which this is the PD8 module. Gives me 7 Anderson connector plugins. These are good up to 45 amps, which I think I've only got a 30 amp fuse on that. And I'm still missing the back cover here on my little doghouse. And this is all 3D printed. I 3D printed all of this, the base plate, then the walls, then the top plate here. This stuff I bought on Amazon, same with that. Finest Chinesium. I don't trust this meter that much. It's not the most accurate, but it works, gives me an idea. The battery, 86% charged. That's probably not right. It's probably about 98% charged. I haven't really, all I've done with it since having it fully charged last time is charge my cell phone and my hotspot maybe 2 or 3 times, which the thing should be able to do that for a year. But anyway, so I try to keep it all nice and compact. I've got a Pelican box here on the floor. That is what I've designed this thing to sit inside of. And it just barely fits in there actually. The lid just barely closes without touching anything. And as far as recharging goes, my plan is I've got a bus bar coming that I'm gonna add here. I've got a DC to DC charger that I still need to add to this thing. This is to quickly charge it from the from a car battery. And then of course I might add a solar controller too and some solar cells, but my main goal was to get it operational. At the moment I charge it, I've got this cord here. I charge it with a 5 amp battery charger that plugs into the wall, that actually made by the same company that makes this battery. And that works quite well, but so far so good. It's working to satisfaction. Mr. Will Prowse had done a review on this battery. Unfortunately, I bought it before I saw that review. And overall, it was a positive review. The big negative he had is when he tested the BMS on the battery management system. When he froze the battery, it still allowed the battery to take a charge, even like at 20 degrees Fahrenheit, which it's not supposed to do. You know, it's because you can damage these batteries when you charge them below the point of freezing, you know, 0 degrees Celsius, 32 Fahrenheit. So that was a big negative he had. Other than that, it actually exceeded the rated capacity. I think when he ran it, I think he got like 205 amp hours out of it. So that's good. But anyway, this is my battery, work in progress. Got a few more components coming to clean it up a little bit, and I want to use some Anderson connectors with plugs to plug in the DC to DC charger and also the solar panels and so on. So I'm still going to add all of that, but right now I'm happy with it. I've only tested it with my heat gun so far, which showed it to, on the low setting on the heat gun, it was sucking 55 amps. So that's a good test for the inverter, but it powered it, no problems. My goal was also that I'm able to run my refrigerator. I'm a little leery with it being a modified sine wave inverter. Because I have noticed that when I run my little fan with it, it makes a humming sound, which I don't like. So I might actually replace this with a true sine wave inverter, pure sine wave inverter, whatever it's called. Renogy is kind of usually my go-to on all that. Anyway, so this is my battery. Give it a quick test here with this thing, 1500 watt heat gun. This thing sucks a lot of juice. Inverter is turned on. 57.2 amps, and let's go to high. Wow. Back to low. And the fan on the inverter just kicked on. Cable is a little bit warm. Yeah, this is an abnormally high load. I'm not usually going to be running that, but it powered it. Sounds just like when I plug it in the wall, so all good. Testing my fan here on low speed. Yeah, I don't know if you hear it on this video, he's got a hum. It's not super noticeable, but you definitely hear it when there's no other noises, which you don't hear at all when it's plugged into the wall. So what worries me about that is if I decide to hook it up to try to run a refrigerator. And that's probably the difference between a modified sine wave and pure sine wave inverter. The inverter literature claims you can run anything with it, but I don't know. I don't want to blow anything up.